Excited. Okay, so this is 2.2. This is the only thing we're doing in section 2.2 is talking about functions. There's 3 things we're going to do with functions. We're going to determine if a relationship is a function. We're going to evaluate functions, and then we're going to have a little throwback to Algebra 2 when we evaluated piecewise functions. So, yay, hey. So the first thing, let's talk about testing for functions. There's 2 ways you can test for a function. If you have a graph, let's say a graph like this, and I have a graph like this. One of these is a function, one of these is not a function. Which is which? Do you remember? Huh?
The first one's a function.
Okay, the one on the left is a function. And why is that? Why? Yeah. You could think of it that way. I've never thought of it as the y-axis. I've thought of it as the vertical line test, which the y-axis is a vertical line. And if it touches a vertical line, or the y-axis, twice, it's not a function. This one is a function because it only has one output for every input. This one, if I had an input on this x, it has 2 outputs. So it's not a function. The example that I always use when I teach this in Algebra 2 is if I go to a pop machine and I put in my $1 and I hit my Diet Coke and I get a Diet Coke and I get a Sprite, the pop machine is not functioning. You're only supposed to get one output for each input. So the other way to test for it is to look at a table. If I have something like this, and I have 1, 2, 3, 1, 2, 3 as my inputs, if I input 1 and I output a 5, I input 2, I output a 6, I input 3, I output a 7, I input a 1 and I output an 8, now this is not a function because you can't input the same number and get 2 different answers for it. It's like if I gave you an equation, y equals 3x plus 1. There's no x value I could plug in here and get 2 different answers. If I plug in a 1, 1 times 3 plus 1 is 4. There's no way to get 4 and a 7. You have to get just one output. So when you're looking at a table, you want to make sure each x value only has one y value. But you could have something like this. 1, 2, 3, 4, 4, 4. This is a function because it doesn't matter that it's the same output. It just matters that I didn't plug in a 1 and get a 4 and a 5.
So you always have to make sure there's only one y.
For the x value. So if I wanted to make this not a function, I could put 1 and then output anything other than 4 because I'm now saying that 1 can give me 2 different outputs. Okay, you'll get some practice time with that. But it's going to come back to you. I promise. Okay, moving along if you guys are okay with this.
I need to write down the graph.
We're going to go on to function notation, which just changes the y. What is the y going to change to? What's the fancy y that we did?
F of x.
Yes, f of x. F of x is just a fancy y. The reason we use f of x is because it can show us 2 things. It names the function with the letter, because you could have g of x or h of x. Put your phone away, please. So it names the letter, or it names the function that you are using. It also shows you your input, what you're going to input into x. So if I have f of x equals 3x plus 2, I'm not real creative today with my whatever. If I then change this to f of 2, where am I going to put this 2? Where the x is. This tells me what my input is going to be into the function.
I remember this one.
Yeah, you guys have all done this before. But I'm going to math it up just a little bit for your example. So this is function notation. Tells you the name of the function and what your input's going to be. Okay? Now, let's talk about evaluating and let's math it up just a little bit.
Wait, so F is name of the function?
Yeah, the letter tells you the name, because sometimes you'll have different letters. In fact, I didn't even look down, but this example is g of x, but I'm going to leave it f of x. Okay, we're going to have negative x squared plus 4x plus 1. So here's my function. Its name is f. Right now its input is x. Now I'm going to say, okay, let's do f of 2. I'm going to put 2 everywhere I see what? An x. So in this case I have negative, and then there's 2 squared, plus 4 times 2 plus 1. And I can evaluate this. 2 squared is 4, and then I've got a negative sitting out front, so it's negative 4, plus 8 plus 1. So when I evaluate this, I get 4 plus 1 is 5.
What? You're just gonna ignore that E?
Negative 4 plus 8 is 4 plus 1 is 5.
Wouldn't that
I
make
just-
the 4 positive, the squared?
Well, we didn't square the whole thing. The negative's out front.
No.
The neg-
No, you combine.
We're just adding. We're just adding.
If you put it in a calculator, can you put the 2 in quotations or we don't?
You can put the 2 there, but you need the negative out front. Because this wasn't negative 2 squared. It was negative and then 2 squared. So that's why that became a negative 4. Now, if the 2 would have been, if the 2 was being squared and negative, then it would become positive. But that negative is just out front. Okay? Now, I'm math it up just a little bit more. You told me that this tells you what you're going to put in for x. So what if I tell you, now we're going to do f of x plus 2. Where am I going to put the x plus 2? Wherever you see an x, just like you did with a 2, you're going to replace it with x plus 2. So I'm going to go in, and I've got my negative out front. And then I've got x plus 2. Oh, I don't usually do my 2's like that. Squared. And then I've got plus 4. And then instead of writing x, what am I writing? X plus 2. And then I've got plus 1. So this one's going to take a little more work because I have this whole binomial that's being squared. So we can't just put the squared in. We're going to have to either do the box method or FOIL, whatever you like to do with this x plus 2. So I'm going to do that work over here. If I have x plus 2 squared, that's like saying x plus 2 times x plus 2. So I have x squared plus 2x plus 2x plus 4. So I have negative x squared plus 4x plus 4. Everybody okay with that? I just took and multiplied this. So what do I need to do with this negative that's out front? Distribute it. So I have negative x squared minus 4x minus 4. Distribute this 4 in. Plus 4x plus 8. And then this little plus 1 at the end. And what's our last step? Just combine like terms. Very good. So our last step is combine like terms. Nothing with the negative x squared, so that just stays. The negative 4x and the 4x are going to simplify out. And then we're back to the same numbers we just had a minute ago. Negative 4, 8, and 1. And what does that become? 5. Good. Easy enough. Okay. I'm going to move on to piecewise if you guys are okay with that. So the hardest part of this one is knowing that when you have that quantity squared to go do this. So don't forget that when you've got a quantity being squared, you either FOIL or do the box method. Okay, last thing, and I taught you guys this, Mrs. Carroll taught you this, so you've seen it before. But this is a piecewise function, which means you're taking a piece from each function and making a graph. Actually, we used to do it like this. If x is less than 0, and then x minus 1 if x is greater than or equal to 0. So this is called a piecewise function. What you're going to do is you're going to figure out what your input is and decide which one you're going to use. This is kind of like when you go get your schedule at the beginning of the year, you go to the table that has your last name. So you can't just go over to any random table and pick up a schedule. You have a specific one to go to. So if I give you this and then I say, okay, we're going to find f of -1. What is my x value for f of -1? What's my input? -1. So I need to go to where the x's, where -1 is included. That's when you're looking at these if statements here. Here, you're using this equation if your x is less than 0. So if your input is less than 0, you're going to use the top equation. You're going to use the bottom one if your x is 0 or greater. Our input is -1. So where does it fall? The top or the bottom? The top, because all of our x's that are less than 0 go to this line and use this equation. So I'm going to plug in -1 squared plus 1. Now this is different than what we just did because this one is in parentheses. So -1 squared is 1 plus 1 would give you an output of 2. Okay? What if I said, okay, now let's find f of 0. Where does 0 fall? The bottom one, because that's where x is equal to 0. So I'm going to plug into the bottom one, and I have 0 minus 1, and I got -1. And what if I said, okay, now let's find f of 4? Where would you put that one? I'm just giving you examples. The bottom one, why the bottom one? Because those where the x's go that are greater than 0, and this x is greater than 0. So I have 4 minus 1 equals 3. And that's that. How was that for today's Friday lesson?
Great.
So good. Okay, let me see how much time I've got left. Friday, second hour, 40. I've got 23 minutes, and I don't have that many problems, so this should work out just fine. We'll go over this on Monday. I'll look at these problems too, see if we need to change anything. But I think it'll probably be all right. Okay. Okay, I'm changing it already, because I know we're going to go 1 through 8, not 1 through 10. And then 23, well, that's easy, plugging in numbers, 33, yep, you guys will be fine.